Welcome to the second lesson on indices. Today we're going to look at rule number 2. Yesterday we learned that with multiplication we add the indices together, and so today, and I think it makes a lot of sense, when we are dividing terms which have the same base, we're going to see that we just subtract the indices. Quick reminder, indices are these little numbers up at the top, sometimes call them powers and exponents. We're going to just look at this first example a little bit more in full so that we can understand why we're subtracting these indices. One thing that hopefully we understand is that 2 to the power of 5 means 2 multiplied by itself 5 times. So here we've got 2 times 2 times 2 times 2 times 2. Dividing, I'm going to write this as a fraction. I really like having my divisions written as fractions, and you'll see that we do that in the second example anyway. And we're dividing that by 2 2's multiplied together, or 2 squared. And remember, this whole set of lessons on indices is about writing repeated multiplication more succinctly. And what we've got to work out here is, well, how many 2's am I actually multiplying? And if we have a little look, what we've got in the first instance, we've got 5 2's multiplying together. But then we're dividing by these 2 2's. And what happens is one of these multiplications is effectively undone by one of these divisions. Yeah, multiplication and division being the opposite processes of one another. And then a second one of these multiplications is undone by this other division. And so what we end up with is just 3 2's multiplying together, and we write that as 2 to the power of 3, or 2 cubed. What we're really doing, and what we really want to get to today, is this idea that we take our indices, and today we're going to subtract them. So when we're dividing terms, we subtract. The second example, I've got it set up like fractions, but it's still just division. I'm going to do this more quickly this time. So we've got 3 is our base. And like yesterday, the bases have to match. If this was 3 to the power of 6 divided by 5 to the power of 4, this rule wouldn't apply. So we've got 6 of them on the top. 4 of these undo 4 of those multiplications. Yeah, so we're doing 6 multiplications, or 6 lots of 3 multiplying together. 4 of them are undone, so we really only end up with 2 of them happening at all. So we get 3 squared, again, subtracting our indices from one another. Okay, and the last example here, we've got x to the power of 8 divided by x to the power of 5. And this is just to let you see one with some algebra, but to see that the rule still applies. So we've got our base of x, we've got 8 x's in the first instance. 5 of these undo 5 of those multiplications from the top, leaving me with only 3 multiplications happening. And again, whether it's letters or numbers, we are subtracting those indices. Like yesterday's lesson, we're going to have a look at a couple more complex examples. So we've got 2 of them here. We've got one where we've got a negative index involved, and how do we process that? And then a second one where we've got these coefficients, the big numbers in front of the letters, that we need to just think a little bit more carefully about how we are going to process those. Okay, up to this one, fairly standard in terms of layout. What we're really focusing on is this negative index here. We're dividing, and so we can see that we're going to have the same base, a. When we divide terms with the same base, these indices subtract. Thinking really carefully about what this gives us, it's 3, we're subtracting negative 2. Yes, subtracting negative 2. When we subtract a negative, it's like addition, so we actually are doing 3 plus 2, which gives me a to the power of 5. So a wee tricky example there, but once you understand the rules, hopefully they're straightforward as well. And then this last question, a lot like yesterday, we've got to think about, what do we do with these big numbers, these coefficients at the front? Yeah, we've got this rule for indices, does it apply here too? And the answer is no. These numbers, these coefficients, just do what the operator is telling us. Now, we can't see an operator like the division sign, but we know that this fraction setup means division. So I like to do this in a couple of steps. We're going to take the 8 and divide it by 4, and that's going to give me a new coefficient of 2. We are dealing with a base of b, and then our rules that we're looking at, this rule of indices, tells us that if we're dividing, we subtract these indices from one another. So 6 take away 3 makes this 2b cubed. Okay, feel free to watch the video again if I've gone through that a bit quickly, but hopefully that helps you with today's task, looking at rule 2 of indices.